is we're going to start a project this week where we have to purify water that has been taken from a water source from a natural disaster, say like a hurricane or a flood, where a place doesn't have any clean water. And we're going to be engineers that are charged with cleaning the water supply so that we have potable water. And by potable water I mean water that can be consumed by people. We're going to have to get 3 different sources of water. We're going to have to get water for human consumption, water that's safe for animals, and water that's safe for plants, because the flooded area has destroyed all of the plants. So we have to plant gardens and make water that is good enough to use in plants to get the plants growing again in the area. So we're going to have 3 test tubes, and each of the test tubes, you'll notice, has graduations on it, and each of the graduations is milliliters. So we're starting off at 2 milliliters and going all the way up to 14 milliliters. I'm going to give everybody in the class 75 milliliters of contaminated water, and this contaminated water came directly from this sort of grungy looking bottle of contaminated water. You're going to get a funnel, and the funnel is going to be for the purposes of adding the clean water to the test tube. And what you'll have to do is label your test tube people, animals, and plants. Everybody's going to get a filter, and in order to get this filter to work in this funnel, what you have to do is learn how to fold a filter. So you have to fold it in half, like so, and then fold it again into a quarter, like so. And then you have to just go in, if you notice that it's unfolded, but I have to pick out one section, and I'm going to place it inside of my funnel. It's going to come out a little bit, but once you get your things in it, it'll stay in. And I'm going to give you 3 different types of filtering materials. The first one is charcoal. Charcoal filter, it's something that we use in homes. People who have fish know that you have to get charcoal for your fish tank. I'm going to give you some pebbles, small pebbles, sort of like rough pebble-shaped objects. And then I'm going to give you some grainy sand. There's, fine sand particles in it and a little bit larger sand particles. And these are natural filtering agents that would sort of mimic what you would see in the ground when the ground filters water. You'll see pebbles in the ground, you'll see sand in the ground. You probably wouldn't see charcoal, but there's organic ingredients in the ground that would do the same thing as charcoal. And we know that the ground filters water because we talked about percolation in the water cycle. So what you're charged with doing is purifying water. And it's your job or your team's job to determine which particles would make the best filters. Maybe you could use a combination of all 3 or just one. And it's your job to determine which ones you're going to use. So you need to talk with your partners, maybe look up some information, and find out what would be the best way to filter. And think about some of the things that we've learned in class this year as well. So I am just going to demonstrate. Please don't think this is the correct way to do it, but I'm just going to demonstrate what you're going to have to do. You're going to have to make a natural filter. So I think I'll put some sand in there. Some pebbles, and some charcoal, and I've got a natural filter going on here. And what I'll have to do is take my water, my 75 milliliters, and don't forget this water is very precious because this is the only water that we have. You'll only get 75 milliliters, so you don't want to spill any or lose any. Because what's going to happen is I'm going to pay you $10 for every milliliter of potable water you produce, $7 for every milliliter of water you produce for animals, and $5 for every milliliter of water you produce for plants. And whoever is able to clean the water, and you have to have all three types, because don't forget, we can't just keep the humans alive, because if the humans are alive, they won't have animals to eat, to consume, and the animals won't have any plants to consume if you only focus on the human potable water. And what you'll have to do is make a certain amount of each type of water so that you can keep the population alive. But you're also a company, so what you have to do is make money for your company. So you're actually working as real scientists in the real world, trying to purify water. And what I will do is, once you bring me your purified water samples, you've completed your task, your project, what I will do is determine whether or not you have produced potable water, and I'll do some tests. One of the tests I'll do is a pH test, and we've done this before, where you test the pH, and the pH of water is generally in the 6 to 8 range. I'm going to look for 7. The animal water will have to be about the same, and this water can be within the 5 to 9 range, the plant water. And I'll also look to see that the sort of blackish color of the water has been cleaned and it doesn't have any suspension in it. So that's what you're going to be doing for this week. You'll have to do some write-ups, which I'll have on the board, but I want to make sure that everybody understands what your task is. Okay, so if you've noticed, I have retrieved some filtered water, 3 milliliters, from the original amount that I put in. But if you look, I've set my filter over here and I've still got some water filtering. So you don't want to lose any of this water, because don't forget, you only get 75 milliliters to start off with. And if you look closely at this, you can see, let's compare it to the original one. It's quite a bit clearer than the original. But if I had a glass of water that had this sort of gray tinge to it, I probably would not drink it. So what I would probably do in this case is, let's just demonstrate. I would put it in a brand new test tube, and I would take that partially filtered water, and I would run it through the filter again to give it a second filtration. Make sure you give it a little tap on the end so you get it all out. You wouldn't be working with small amounts like this, but because we're in a classroom, we're just working with small amounts. You'd be working with, thousands and thousands of liters, tens of thousands of liters of water, just like our video. Okay,